In today's lesson, we're going to learn a little bit more about square roots. You are required to take notes, so please get your pen and paper out now if you don't already have them out. We talked briefly about the definition of a square root. We talked about how they're the opposite of squaring something. And we're confusing. It says a square root is what number, when multiplied by itself, is equal to that. That's the confusing way to say it. But if you just look at it as the opposite of squaring, and over here I listed some opposites. We have addition and subtraction, multiplication, division, squaring, and square rooting, okay? So for example, when you see this symbol, that's a mathematical process. It's not just a roof over a number. It's not the division. It's a process. It says, hey, tell me what squared equals this number. Okay, so that's what you're going to ask. What squared equals 36? And of course, we all know that's 6. Common misconception, because you think about multiplied by itself, you know there has to be 2 numbers. A lot of people like to divide by 2. That is absolutely not the case. This is the best question you can ask yourself for any one of these problems that we're going to be dealing with in this unit, okay? Let's take a look at some other things here. Every positive number has actually 2 square roots. And I kind of want you to think about how or why for a moment. And I'll talk you through how and why in a moment. Okay, let me give you a hint. What are the rules of multiplying negatives? Hopefully you have it. This could be 6 times 6 or negative 6 times negative 6, because you know that a negative times a negative equals a positive. So every positive whole number, every positive number, not even just a whole number, but every positive number has 2 roots, okay? So here's the thing. What about this? What if there's a negative sign out front? Well, you're still going to ask yourself what squared is 16, and that is 4. And this is on the outside. So this just comes over here and sits out in front of it. It's kind of like when you have a negative x. Remember that is the same as negative 1 times x. So when you look at a negative in front of a radical, it's the same as negative 1 times the square root of 16. Okay? Square root of 16 is 4 or negative 4. But since the negative is right out front, the answer will always be negative. I'm going to show you a different placement for that negative number. What if it's inside the radical? Try to figure out that. What do you think the answer to that would be? And I want you to ask this question. What squared equals negative 16? It's not 4. Because 4 times 4 equals positive 16. Negative 4 times negative 4 equals positive 16. And it's a number squared. I cannot take 4 times negative 4. That's not squaring. 4 and negative 4 are different numbers. Okay, so the actual answer to this, if you see a negative sign in a radical, it's mathematically impossible. It's impossible to square a number and get anything negative. There's no half negative. Okay, so that's something you need to look for, and you're going to see that. Just remember this is what's called undefined, or it's not like a real number. There is no answer to this when that negative sign is under the radical with that number, okay? 0 only has itself. It's the only one that doesn't have 2. Square root of 0, because 0 is neither negative nor positive. That is the only number that has 1 root. Everything else has 2. Okay, so this is pretty basic stuff. It's pretty easy, just a few things to remember, like these negative signs. Let's take a look at other ways we can use it. Okay. you're going to see the words perfect square. And so far, that's what I've been using because they perfectly come out, right? Okay, to a whole number. That's what a perfect square is. When the square root is a whole number. Because I can find the square root of 2, but what times itself, what squared equals 2? It's not 1, it's certainly not 2, so it's going to be somewhere in between here, which means it's a decimal. That's not a perfect square. Perfect squares mean they're nice and easy, and you get nice whole numbers as answers. So here's a few examples of them. 49. What squared? That's the exponent of 2. Okay, you probably already actually have all 3 of these answers. 7 times 7, this is 9 times 9, this is 11 times 11. Notice I'm not writing 11 times 11. I'm just writing number because, I'm just writing 11 because the question is what number squared? It's 11. So let's take a second to list all the perfect squares up to about 10 or so. I think I went to 13 because I like that number. Okay, so just pause the video and fill these in for yourself. It's good to have these listed. Pause the video and go ahead and do that now. Okay, hopefully you have them all done. 3 times 3 is 9. You can see that right there. There's a lot of patterns to these numbers if you start looking at it, like ends in 4, 9, 6, 5, 6, 9, 4, 1, 0, 1, 9. Okay, this is when it starts over again. Not for a while, but there's different counting theories and stuff you can use with these, but we're just going to deal with it as it is. There's other perfect squares, obviously, that go up a little bit higher, but we're just going to stick with some of these basics for now. You're going to see questions like this, and this is one big line. So it says 8 squared equals 64. So then the square root of 64 must equal 8. Okay, it's pretty logical process to follow. I just wanted to kind of show you. You will see a couple questions like this on MathXL, and it's basic. What about fractions? How does that work? Well, a fraction is a number over a number, and they're both inside the radical. So what if I did that? Does that make it easier? I certainly hope so. Okay, so what you're going to do is write it as a separate square root. Okay, I already did that over here. Then you evaluate the square roots, meaning what number squared equals this? Okay, if you need to simplify after the roots are found, then you can do that, but this is already in lowest terms. So we're going to take a look at a couple more examples of fractions. I want you to pause the video and try all of these. Please remember to reduce each one of these into its lowest form, or MathXL will count it wrong, and so will I. I will take points off for that. So go ahead and try that now. All right, so here are the answers that I got. Hopefully that wasn't too hard. I didn't show how I wrote them as separate roots, you know, square root of 9 over the square root of 49. So hopefully that's a step you can start to skip in the future. I just kind of wanted to show you how it breaks apart like that. So this is pretty easy. Okay. Another way we're going to use square roots is in order of operations. Remember PEMDAS? Where do you see square root in there? That's not the S. Square roots fall into the same place as exponents. That's when you want to do your roots as well. So when we look at this particular example, you're going to have 15 plus 4 plus, go ahead and do that, 6. And it's really that simple. Obviously, I have some problems that get a little bit more involved in that, but that's, I don't think I have anything else on here. That's a pretty good start today on what you're going to be doing with exponents. We'll get into simplifying unperfect squares, but for now, we're going to stick with this.